Welcome everyone to our next Master Lecture in the Go Fly Master Lecture series with Carl Dietrich, co-founder and CTO of Terrafugia. As you know, Boeing is our grand sponsor of the Go Fly Prize, and we are joined by corporate sponsor Pratt & Whitney, as well as over 20 aerospace and STEM organizations around the world. Today, Carl will be speaking about the story of Terrafugia. He received his BS and MS and Ph.D. from the Department of Aeronautics and Astronautics at the Massachusetts Institute of Technology shortly after receiving the prestigious Lemelson-MIT Student Prize for Innovation in 2006. Carl was also recognized by the Aero Astro Department at MIT as one of the 16 exceptional graduates under the age of 35. In addition, Carl has received 40 Under 40 awards from the Boston Business Journal and Aviation Week and Space Technology magazine. Carl has spoken internationally and is generally regarded as the leader of the emerging modern flying car industry. He has been a private pilot since the age of 17. So it's my pleasure to welcome Carl today.
Great, thanks for having me. It's really exciting to be here. I remember when Gwen first started talking about creating the Go Fly Prize, and it's really awesome to see how it's grown since that time. So let me see if I can share my screen here. Yeah. All right. There we go. Can you see it?
We can. It looks like it's in it needs to go into the full presentation mode if you can.
How about now?
Perfect.
Great. Okay, so as was stated, this is really going to be a bit of the history of Terrafugia, where we came from, some of the struggles that we encountered along the way. I'm assuming that many of you guys are going to be trying to build a company out of the work that you're putting into the Go Fly Prize. And it's my hope that there are some lessons to be learned from Terrafugia's experience in the not too distant past. So with that, let's get right into it. So Terrafugia was founded by myself and 4 other co-founders coming out of MIT, looking to capitalize on the nation's largest underutilized transportation resource, this network of over 5,000 public use airports around the United States. Most of these airports are nowhere near the capacity. It's really only the 27 major international airports that really push the limits of flight operations. So with this huge network of airports and basically an old general aviation industry, we decided, well, what could we do with this infrastructure and with the technology that we have today to make better use of this existing resource and help people get around more seamlessly, make better use of personal aviation. And that was the story behind the founding of Terrafugia. Of course, it was catalyzed also by the emergence of the Sport Pilot Light Sport Aircraft rule, which changed the way you could certify an aircraft or bring an aircraft to market, opening the window to do something a little bit more novel than what was previously allowed through traditional Part 23, Amendment 62 type certification process. We put together a business plan, and really the key part of a business plan is really outlining the problem that you're trying to solve. In our case, it's really why more people don't fly themselves in personal aircraft. And it turns out that a lot of work had been done studying this problem prior to Terrafugia. The first is that it's just a lot of time and a lot of money to become a pilot initially, so a huge barrier to entry. And then once you are a pilot, even those 600,000 or so people who are pilots are inhibited from flying on a regular basis by these 4 factors: extreme weather sensitivity, high recurring costs of ownership, long door-to-door travel time, and relatively limited ground mobility at most airports. Now, these problems have been statistically identified by a survey of about 1,500 pilots back in the early 2000s. And it's no big surprise if you go out and you talk to pilots today why they don't fly more often. Some combination of these factors will usually come up. So what we set out to do was create a business that would try to solve this problem in a way that the other competitors in the space really weren't addressing at this time. We were a startup. We could afford to take a bigger risk. We didn't want to go head-to-head with Cessna or with Piper or Cirrus or any of the big players in the space. We needed to carve out our own unique niche. And when we looked at these problems, we said, well, you know what? The weather sensitivity, the long door-to-door travel time, and the limited ground mobility could all be addressed by a combined flying driving vehicle. And then if that combined flying driving vehicle could increase the utilization, it might be possible to address the high recurring ownership costs. So that was the idea that, that really was the beginning of Terrafugia, or the beginning of this idea of how to make flying more practical, how to make a practical flying car. So we set out to create a vehicle that could fit inside a standard construction single car garage, that could drive on normal roads and highways at highway speeds, that would run on traditional automotive gasoline, that you would drive to the airport, unfold the wings, like putting the top down on a convertible, and fly like a normal general aviation airplane. We wanted the vehicle to be able to fly significantly faster than it could drive on the road. And for us, that meant triple digits miles per hour, so 100 miles an hour cruise speed. With that, there were a lot of other concepts that we looked at for, powered parachutes and other things of that nature that had lower certification barriers and lower technical challenges, but it really didn't make sense because they tended to cruise basically at about speed equivalent to or lower than the vehicle could drive. And of course, the vehicle had to be certifiable for driving on the road. So that meant you had to be able to get a license plate in all 50 states. You had to meet federal motor vehicle safety standards for driving on the road. And that, it turns out, that is a major, major challenge to meet all of the certification requirements simultaneously, both from the aviation side and the automotive side. So with the Terrafugia transition, we believed that we had a concept that could address all of the barriers to the more widespread use of personal aviation. First, by bringing it to market in the sport pilot light sport aircraft category, we could minimize the training required. As a sport pilot, you're required to have at least 20 hours of training, so it's about half the traditional for private pilots. In reality, we're seeing sport pilots get their ticket on average in about 38 hours. So it is significantly more than that 20-hour minimum, but it's still quite a bit less than the traditional private pilot license, which averaged around 70 hours or so. The extreme weather sensitivity was mitigated by the fact that the transition could drive in bad weather. So when you can drive in bad weather, you're more likely to make a flight, for instance, the weekend getaway type mission, where you leave on a Friday and you don't necessarily know what the weather is going to be like Sunday afternoon when you want to come home. That can be an inhibitor on using general aviation today. But if you have a transition, you always know that you can fold up your wings and drive home. So we believe that the flexibility of being able to choose to fly or drive at any point allows the pilot more options, in a sense. The fact that you could drive the plane home, park it in your garage, and that it would run on premium unleaded automotive gasoline instead of 100 low lead avgas meant that we were significantly reducing the recurring cost of ownership in a couple ways, not even accounting for the fact that we might be able to achieve higher utilization. So that was very appealing. And then, of course, the long door-to-door travel time. One of the interesting things that we found when we did a study of typical door-to-door trips is that even though our vehicle is cruising at a much, much lower speed than the best-selling high-performance piston singles like the Cirrus SR22, which might cruise at 150 to 180 knots, somewhere in that ballpark, we're down at 90 knots. Because we spend less time stopped on the ground at the airport, switching between modes of transportation, we can actually beat much higher performance aircraft on door-to-door trips up to about 150 miles or so. And that's pretty compelling because there are a lot of short-range general aviation trips that fit in that sort of ideal range where the transition could actually, on average, beat a much higher performance aircraft on a door-to-door mission. Finally, the fact that most of the 5,200 general aviation airports around the country don't have a rental car counter is not a problem if you have a transition. So we believe that we had a product that could address, one way or another, all of the major obstacles to the more widespread use of general aviation in this product. And that was the essence of the business plan that we put forward. And we started pitching to investors back in 2006. In parallel with creating the business plan, the founding team, the three kind of core co-founders you can see here from the technical side, myself on the right, Dr. Samuel Schweiert in the center, and then Anna Maracek, now Maracek Dietrich, my wife, on the left-hand side. We also were down in the shop building wind tunnel models and doing the studies necessary to kind of test out different configurations, different designs. This is a shot of us at the MIT Wright Brothers wind tunnel, testing out one of the early configurations of the transition, doing some flow viz around the nose. The business plan was actually quite well received by the MIT entrepreneurial community. We entered into the MIT 100K business plan competition. And back in 2006, we were actually the runner-up that year for all business plans, and that was competing against Web 2.0, a bunch of other startup ventures that were far less capital intensive, more traditional software type companies and things of that nature. And that was really encouraging for us. That gave us not only a nice $10,000 prize and some great publicity, but it really also gave us a little bit of external validation that we think we're onto something here. There's a real problem here that we're addressing with our company. So this is a picture of the 5 co-founders holding the check on the left, and one of the organizers of the prize. In the background, you can see Dean Kamen there on the left-hand side. So that was in May 2006. We started working kind of on the side of, life. And at that time, I was still working on my Ph.D. We had a number of other folks that were working full-time elsewhere. We decided that what we would do is take the $10,000 from that prize, and part of the $30,000 that I won as part of the Lemelson-MIT Prize for inventiveness, and bring our fledgling company that had just been incorporated in May of 2006 to the largest trade show in general aviation. That's AirVenture Oshkosh. And that show was at the end of July every year in Oshkosh, Wisconsin. And it really is sort of the mecca for our industry, for the general aviation industry. And at that show, all we basically had were some computer graphics, which you see on the back wall, the banner there, and the wind tunnel model, some machined parts that we had made ourselves in the student machine shop for parts of our first generation wing folding mechanism, the highest risk component of the vehicle. And we showed those parts and the concept at this show, and we took refundable deposits. And at that show, we actually had 7 people write checks to hold a place in line to buy a transition. And for the founding team, that really was the next level of validation that, okay, there really are people who are ready to pay money for this solution. And that type of early business validation is so critical. And it really helps us identify who the stakeholders are, what they care about, what assumptions that we had are correct, and what need to be refined. It took us another, I guess, 5 months to pull together our first external financing of the company. And that first bridge round of investment was only about $250,000. That money came in December of 2006. And again, we didn't have anything other than, we didn't have any office space at that time or anything like that. This is the sort of celebratory picture at the closing of that first round of investment. And you'll see kind of the key co-founders. We had employee number 1 lined up. We had a few of our early investors there. This picture was taken at the MIT Entrepreneurship Center, which really helped the company get off the ground in the early years. So with that money, we then moved into a small 3,800 square foot garage on the south side of Woburn, Massachusetts. And we started doing the design and build work on our first generation wing folding mechanism, which we determined to be kind of the highest risk component of the transition vehicle. So you can see myself and Dr. Samuel Schreier working on the first generation wing fold mechanism, the wing on a stand. And what you can't see off to the left-hand side is there's just a stand there. And we moved into that facility, I think, in February of 2007, and took that wing on a stand to Oshkosh in 2007. And then we started building the plug and molds that we would use to make our first full-scale proof of concept vehicle. So it was all in this small garage space. I think at that point we had like 8 people that were involved with the company. These are the various components of the proof of concept vehicle that we built out of the molds that we made. We used very simple construction. We did use some pre-preg material with PVC core. And we built the proof of concept vehicle really over the course of the fall of 2007, spring of 2008. By the summer of 2008, we were starting to do ground driving tests and taxi tests in the parking lot and at the local airport. This is a picture of the proof of concept without the wings on, without a cowl on the engine, doing some early testing. We took the fully completed shell of the proof of concept vehicle back to Oshkosh in 2008. And at this point, what you see here, I don't think we had the engine installed yet at this point. So those pictures may be a little bit out of order. But the vehicle, basically, it looked like the whole package, what we had set out to do a couple years earlier. And it helped us get more orders, more folks put down deposits. We were able to demonstrate the wing folding mechanism at Oshkosh that year on the full vehicle. And at that time, we were really trying to build credibility around the concept of a street legal airplane or a roadable aircraft and distinguish it a little bit from the term flying car, because the media loves to call things flying cars because, frankly, the term flying cars sells magazines and it's what the general public understands. But we, at the time, thought that there really wasn't a lot of, that the term flying car was associated with a lot of science fiction and not reality. And so we were trying to ground the company in a little bit more reality and less with the sci-fi side of things. Since then, you guys will see that our marketing and branding has evolved to basically try to capitalize more on the term flying car instead of disassociate our company from that term. But early on, that was what we felt like we needed to do. So fall 2008, after coming back from Oshkosh, we installed the engine and we started doing taxi tests and low and high speed tests. And we actually had our Series A financing lined up to come together. The first valuation of the company was lined up to come together October 15th, 2008. And as many of you guys know, there was a huge economic collapse just prior to that time, and we had a lot of our investors, many of whom were also customers of the company, that had kind of given commitments to participate in that Series A round, basically looking at their portfolio and seeing it drop by 30, 40% in a very short period of time, and reevaluating their commitments to doing high-risk type investing, like investing in a flying car company. So the deal actually fell through. Our Series A financing fell through, in part because of the financial collapse. And we were within about 2 weeks of shutting our doors, laying everybody off. Unfortunately, I was able to get on the horn with a few of the key customers and people who had already invested in bridge rounds, and pulled together a new, much smaller round at a much lower valuation. And it was going to keep the company small for a much longer period of time, but it kept the doors open and kept the company going. So, you know, this would have been a really good time to to throw in the towel if we were ready to, if we were going to quit. But, you know, I think myself and the other co-founders really have a high level of personal commitment to achieving this dream. And so we decided to ride it out and, you know, do the smaller round at the much lower valuation and keep the doors open, keep the lights on, and keep pushing forward. So basically we had said, look, we're in a position where we wanted to close the Series A prior to flying the vehicle for the first time, and with the idea that after we flew the vehicle for the first time, it was going to get a lot of publicity, and we were going to be able to do a much larger Series B at a higher valuation, and that would be good for all the Series A investors who had just gotten in prior to that. And so our initial target was to do our first flight in December of 2008. And so we were up at Plattsburgh Airport, which is a 2-mile long runway, an old SAC base, right? We could take off and land, like, in theory, 3 times down the length of this 2-mile runway. And it was snowing and what have you, and we actually we gradually ramped up step by step, you know, low speed taxi, high speed taxi. We did a number of high speed taxi tests, and we actually encountered in our high speed taxi tests some issues where we thought the vehicle was going to be able to rotate and leave the ground, and it didn't, right? So we were out there and we thought we were going to have wheels off the ground, and Phil pulled back and nothing happened. Phil's our test pilot. And so let's just say there was not a small amount of concern about this. And we had some early indications that we were going to have some problems, like our propeller actually simply wasn't grabbing enough air. We were redlining the engine too easily. We weren't getting all the power out of the engine that we could. So we were barely getting up to our rotation speed. So we had a whole bunch of issues with getting the proof of concept up into the air. And we actually came back from that deployment where we thought we were going to fly for the first time without having flown. And at that point, we really thought the company was gone, right? We thought that, you know, there's no way that we're going to be able to pull together more money now, because we thought we were going to be able to fly it. We didn't fly it. And now we're, you know, out of cash, and here we are. What are we going to do? Fortunately, again, it's so key to have investors who truly believe in what you're doing. And so I explained the situation. I explained, look, we think we know what happened. We have data that suggests that our propeller was not grabbing enough air. We weren't able to get up to a high enough speed. It's not, basically the prop was too small, effectively, for the engine. It was a custom-made prop that was an outside contract job. And so the recovery plan was to get a new propeller made, expedited out to us, and go back out as soon as we can to fly again, if we had the money. Which and once again, our investors stepped up and wrote another check to keep the doors open and the lights on, and we finally went out back to Plattsburgh in March of 2009. And well, let me share with you guys the video. And this is a video that we don't publicize on. We never posted any sites or anything like that. This is a behind the scenes video taken with a little handy cam as you were driving down the runway, chasing the vehicle in a pickup truck going down the runway. So I'll play this for you, and you'll see the really, really long takeoff roll. And I should say this was a run that we did with the old propeller, this one that was too small, but we went out really, really early in the morning when the density altitude was like minus 2,000 feet, right? So we thought, well, maybe it's cold enough that the air is dense enough that the prop will grab enough air, and then we can get into the air because otherwise, if you have to replace the prop, you've got to requalify the whole drive line. We've got to redo a whole bunch of static testing, et cetera, et cetera. It would be a little while longer. So anyway, this is the video from that special day for us.
10:28. Put that thing down, Phil.
Oh, it's flying beautifully! Oh my god! Oh, thank God we need 25. Oh, it's so good!
Down!
Yes! Yes! Yes!
Woo! Oh my god!
Woo! Yes!
Drive around. All right, let's do this right.
Welcome back, Phil. Ben, ask Phil if him if it was a soft landing.
Soft landing?
Woo!
Ask him if he had a soft landing and any problems.
He's telling you to come.
All right.
Too, because I couldn't get the airspeed down. It was staying at 90 knots.
All right, so that first flight really did, we took this picture of that first flight from the chase aircraft, the Cessna that was kind of coming along flying chase. And that first flight really allowed us to go out and raise more money. Now, it was still at a very depressed time for the economy. So we didn't raise as much money as we wanted to that time either. But again, it let us move forward, keep the lights on, keep the doors open, hire a few more people. And we started taking the lessons that we had learned from that proof of concept vehicle and developing our next generation vehicle, which we call D2, or Development Vehicle 2. And there were a bunch of changes that we made to that vehicle. At Oshkosh, we announced that, and then we built that vehicle over the next 2 years. We took that second generation design to the New York International Auto Show, which was much more of a mainstream show than Oshkosh. And it was amazing the response that we got just from the general public at that show. So it was truly, you know, touch and go for a number of years. And as you guys get into this space, you know, just I want you to kind of be prepared that this is a long road. Anytime you make something where you're putting somebody's life on the line, you really need to take things very slowly and methodically, do things very, very carefully. But it's possible to do, and it doesn't take a fortune. It can be done. So the second generation vehicle obviously flies much, much better than the first generation vehicle. We didn't have any of the issues with the propeller or anything like that. It more or less flew the way we expected it to, pretty much right from the start. We flew this second generation vehicle for the first time in 2012, and we've actually been flying that vehicle. We flew it. We actually just retired that vehicle finally earlier this year and turned it into a show vehicle. But this second generation vehicle had over 200 hours of flight time on it, about 100 hours of driving. It really was kind of a workhorse, and we learned a tremendous amount more about it that fed into the production design. So again, as you guys are thinking about your business, if you're coming up with something that's truly novel, plan for at least 3 major iterations would be my recommendation. Right. Here's a picture of the inside of Transition D2 during some flight testing. Here's a shot from that we actually took the D2 vehicle to AirVenture Oshkosh and did a live demonstration in front of about 100,000 people in 2013. And I'll share with you guys a video. Here it is coming in for a landing at Plattsburgh also. So let me share with you guys a video from that live demo that we did at Oshkosh. Right out of our at Oshkosh, drove it out to the flight line. It was awesome. We had like kids running by. Obviously, flying much better today than it did back in the first place. We really got lucky doing these demos at Oshkosh. We actually did 2 live demos. And the second one was before the night air show. That's what this one is. The sunset, and really couldn't have asked for a better setting. Summer of 2013 when we did this live demo of Transition at Oshkosh. And actually, it's really interesting because that was a while ago now, right? That was basically 5 years ago. I went out in the wake of that looking for capital to put Transition into production, because it takes a whole nother level of capital to go from prototype what we had then to an actual production aircraft with a production line and all the quality, et cetera, that you need to deliver and support an aircraft. And we had a really, really hard time finding capital. In fact, basically, nobody in the United States wanted to invest in the development of a complex manufactured good. It's got supply chain risk. You're beholden to suppliers. There's all sorts of reasons why a major investment in a production line is very risky and not very attractive to traditional investors. So I started looking overseas in the 2014 timeframe, after I really wasn't getting much traction at all in the US. And I engaged with a number of different consultants to help line up meetings in China. And eventually, by February of 2015, I took investment from a small Chinese venture fund that specialized in connecting US-based companies with Chinese ability to scale into production. And that fund introduced us to a lot of different companies in China, took us on a road show, and they were the ones that connected us to the Zhejiang Geely Holding Group, which wound up investing in Terrafugia first, and then finally acquiring the company in October of 2017. So it was a long haul, and I'm skipping over a lot of stuff in the interest of time, but if you guys have more questions, I'm happy to talk about that, the backstory in the Q&A session. So today, now that we've been acquired, the company's grown like crazy. We now we're in the process of rebranding. We're going away from the three swooshes. We just announced about a week ago that this new T, the flying T kind of thing, is the new logo for Terrafugia. We now have major sister companies. We've got projects going on with our sister companies, Volvo, Lotus, or SEFT, I should say, which is a company that's populated by a lot of Volvo engineers. They're helping us do design of our airbag system, our crash protection. Lotus folks helping with the engine control unit. Our headquarters and engineering facility is still in Woburn, Massachusetts. We now have, I think, about 140 people working there. We have a 10,000 square foot R&D center now in Petaluma, California, that I run, doing development of our next generation vehicles, like these concepts that I'm showing on this slide, concepts for eVTOL aircraft. We also have a flight test center in Nashua, New Hampshire. We have a facility in Linjiang, China, that's planning for production, and the city of Wuhan in China is actually developing a $300 million production facility for Terrafugia products. So we're going to have a campus in China for production. So we are globally now, we're at about 240 employees, and we're growing very quickly. It's a very exciting time at Terrafugia. We've got plans to make transition accessible to lots of pilots, more pilots than can just afford to buy it, through shared use business models. And we're very excited to be participating in this emerging eVTOL space. We have a concept now that we call TF2, which is really a three-part door-to-door transportation system with a flight vehicle, a pod, which can either be a passenger pod or a cargo pod, and a ground vehicle. Again, Terrafugia is all about seamless transition between flying and driving. There are great benefits for this type of system for the end user in terms of providing true door-to-door service. And then for the fleet operator, there are huge benefits in terms of safer and more efficient operations with faster turnaround times. So I want to be sure to leave plenty of time for question and answer here. And I just skimmed the surface of a lot of the story of Terrafugia, but I think I hit on a lot of the key stuff, which is in the early years when we really didn't have a whole lot. and we had to make something of it. So at this point, I would love to open it up for questions and just see what you guys are interested in learning more about.
Thanks so much, Carl. That was incredible to learn about your journey over the past several years. We unfortunately couldn't hear you speak over the two videos. The sound coming through, so I wonder if you want to just highlight some of the things that you were mentioning during those two videos.
Oh boy. I think I was just describing in the first one, the first flight, what was going on in terms of the chase pickup truck on the ground and the chase Cessna 172 in the air that was coming by and picking up the aircraft on the ground. For the second one, on the first one, talking about how the prop was undersized, it wasn't grabbing enough air, and that's why we had such a long ground roll. The second one, it was just more, obviously the vehicle performs much better, the second generation prototype. And it was amazing to do these two live demos in front of 100,000 people or so at the show and share what we were able to do, at least at a prototype level. But then coming off that, again, I thought that we were going to have a tremendous amount of investment interest, and we didn't. Right? Because you're talking about investing in a complex manufactured product. So that was really a challenging time. And we had to, again, decide, okay, what do we throw in the towel even after we've done that? Or do we start going overseas where people are investing in manufacturing and even with complex supply chains? And that's when we decided strategically to start looking in China. So.
Great. One of the first questions we have is there a particular reason why you chose 4 wheels over 3 wheels, which is supposed to be easier to certify?
Yeah, there is. The 3-wheel configuration, so the more stable 3-wheel configuration is 2 in front, 1 in back. If you go with 1 in front, 2 in back, you have issues of rollover during braking, turning maneuvers. And there are a lot of cars out there in the history of cars that have shown that. You can do things that are fancy in terms of trying to keep the thing balanced, like the gyroplane in Europe, I forget what it's called, but they've got active suspension to roll the vehicle. Basically, philosophically, we decided very early on that, look, if we are going to have a shot of being big, we need to make decisions like we are a big company, right, in many ways. Strategically, that means really minimizing the risk. And a 3-wheel vehicle, particularly one with large sail area, is always going to be less stable, more prone to rollover incidents than a 4-wheel vehicle. So we went to a 4-wheel vehicle for stability, for handling on the road, and it did put us in a more challenging certification category. But in the end, that drove us to incorporate more safety features, which we can now legitimately say that the transition is probably the general aviation product with more crash survivability and safety features than any other airplane out there. So, safety is a big concern when you're talking about bringing new people into small flying things. And so going to a higher bar, holding ourselves up to a higher standard, really has helped from the perspective of helping to overcome those concerns that the general public has.
The next question is regarding the CFD package virtual blade model, which was developed by your company. Does your company still actively use this package in development? And if so, is Terrafugia willing to provide additional resources to help others using this package? It seems that user guides online are non-existent.
Terrafugia doesn't distribute any sort of analysis package. So I'm confused by that question. We're not a software company. We don't.
Robert, if you wouldn't mind clarifying that question, perhaps Carl can approach it again. Let's see, another question is, early stage startups with prototypes or design, how can we come up with a valuation of our company for investors? Are there any references we should look for?
You need to talk to your investors. it's a negotiation with your investors. It kind of doesn't matter what anybody else, what other companies are valued at. The only thing that matters is the people who are willing to put money into your company and what they're willing to pay for it, right? So you know, you can use other examples in that negotiation, but in the end, or you can lay things out, like particularly if we did a number of bridge rounds with smaller investors where we said, look, we don't know what the appropriate valuation is for a company at this stage, so we're going to use a convertible debt mechanism, and we're going to offer you a discount to whatever valuation is negotiated at a later time, right? And that type of mechanism we used a lot during the early years to, and that way you could say, you know, the earliest one you maybe give more of a discount to, and then as you get closer and closer to the time where you want to do a priced round, the discount is reduced, and you lay out that that's the plan. And that can help excite individuals to participate in early rounds.
Okay, I'm going to try and clarify the earlier question, Carl. So the innovator is mentioning that the virtual blade model was originally developed by your company, according to a source online. It says, quote, in designing a rotable aircraft, Terrafugia developed a virtual blade modeler that plugged into Fluent and created additional capabilities to model the aircraft's propeller. So is this an open source tool available online that was at one point distributed by ANSYS?
No, I mean, we haven't, I don't know where he found this information. I mean, we did use Fluent at one point a number of years ago, but we never distributed any sort of tools, or we didn't really develop any, well, we developed internal software tools, but we certainly never sold them to outside parties or did one way or another. So I think, you know, so much, I've got to say, after having been in this space for more than a decade now, so many media stories that you read are not well done, not particularly accurate. You know, flying cars sell magazines. People will just repost stuff. They'll play a big game of telephone and they'll never call us or ask us. They'll just repost what they read and interpret it in some little way and put their own spin on it. And it's really kind of disheartening at times. You know, I don't mean to say that about the more credible media, but certainly, I mean, you can find all sorts of garbage online that's just simply not true. So.
Yeah, thanks for the clarification there, Carl. You had spoken about, you know, your process of certification, why you pick certain things over others. I wonder if you can speak a little bit more about your process with the FAA. How did you approach it? What did it look like? What were some lessons that you learned in that process? Sure,
yeah. We had our first meeting with the FAA before we incorporated the company, before we, before we knew what transition might look like. We said, hey, we're thinking about doing a rotable aircraft in this light sport aircraft category. Is there any, and we went to the local ACO, the local aircraft certification office in Burlington, Massachusetts, and met with the person in charge of that office, and this was back in 2005, actually. And, you know, we shared with them kind of where we were in the conceptual design. We had 3 different concepts that we were looking at the time, and we were just very open about who we are, what we're doing. And, you know, they came back and said, look, there's nothing that would inherently prohibit you from doing a rotable aircraft in the light sport aircraft category. There are strict weight limits, there are other things of that nature that will be challenges, but there's no regulation that says that you can't do this. So that was very helpful. And of course, through the years, we've had many meetings with folks inside the FAA, particularly because what we're doing is different than most other aircraft companies. And we had to ask for special consideration, both on a weight perspective. We had to get exemptions from the weight limitations in order to incorporate a bunch of automotive safety features, safety gauge crumple zones, airbags, pre-tensioning low limiting seatbelts, et cetera, et cetera, et cetera, a bunch of stuff that we needed to meet federal motor vehicle safety standards. And we also needed to get exemptions on the NHTSA side. We had to get 4 particular exemptions to certain FMVSS rules. And so having the relationships with both organizations, both NHTSA and the FAA, and having meetings, in-person meetings with these folks was very valuable, both in terms of just increasing the communication bandwidth and helping build understanding between Terrafugia and the regulators with the other regulators also, for that matter. And we continue that. I mean, for these concepts like TF2, which is still very much at a conceptual design stage right now, you know, we've already had meetings with the FAA about that. So certainly, if your plan is to certify something and put something into that's carrying people, I would definitely encourage you to have some pre-application meetings with the FAA.
How much emphasis did your company place on CFD when first developing the transition craft?
We couldn't afford any CFD, any quote unquote real CFD back then. And there wasn't as large of a, like we didn't have as many good free options as we do today in terms of real CFD. We had vortex lattice codes, but basically the POC, the first generation transition POC, was more or less designed with vortex lattice, spreadsheet calculations, and wind tunnel testing. And as a consequence, we actually found some things that were bad assumptions in the early design of the proof of concept. Beyond just I kind of highlighted the big one, which was the prop wasn't well designed, but there were other issues. There was a lot of flow interference between the front wheel pants and the canard on the first generation vehicle, which is why we got rid of the canard in the second generation prototype. So, but it wasn't really until the second generation vehicle that we had the resources to actually get a seat of Fluent and do some real analysis. We also hired a very experienced consultant, Aerodynamics consultant who had worked on 40 different programs to help build our confidence, help us iterate the design a little bit faster. So there were, but you know, and then it really wasn't until we got much farther down the road that we started leaning very, very heavily on CFD. And of course we do most of our work in CFD today at the early concept stage for things like TF2.
So a rather big question, but what has been the hardest thing or some of the hardest things about making revolutionary new technology?
Okay. So if you have a bold vision that is, that's not already sponsored by somebody, you've got to convince people to fund it. Fund the development of it, right? So I spent the majority of my time for the first decade of Terrafugia basically out there being a salesperson for the company. I used to make the joke that, you know, I spent 11 years at MIT and got a Ph.D. in aerospace engineering to become a car salesman. So, but that's a lot of what I was doing early on is basically selling not the vehicle per se, but the company and the vision of what we were trying to achieve. And you've got to do that. You know, you've got to get the backing lined up to do that. And it's a problem that a lot of engineers don't want to deal with. And, you know, they'd much rather have just the money show up, right? Well, somebody's got to pay the bills, right? So that, I would say, was the biggest challenge for me for the first decade of the company, really until the acquisition was complete. Was where is the money going to come from to keep the doors open and the lights on and to keep this team working as efficiently as possible on achieving this vision. And, you know, it's not necessarily what I wanted to be doing, but it was what was necessary in order to achieve the vision, and achieving the vision is what I wanted to be doing.
So feeding onto that question, two follow-ups. One is, so then what are some key tips that you could offer the GoFly community in terms of fundraising? Were there any investors that you turned down? What are some key things that you looked for in investors? You had mentioned several times that it's important that you have good partners for supporting you through and through, especially when things aren't working the way that they need to be working. So what did you look for? How did you become that great car salesman that brought in all this money for the company?
So in terms of, were there any people that you turned down? Yes, although it mostly had to do with the size of the check that they were writing and the level of overhead, because, you know, as the CEO of the company at the time, I was spending a lot of my time courting new investors as well as managing the existing pool of investors. So there were a couple of folks who I thought, wow, this person is going to take more of my time to manage them and keep them aligned with, you know, what we're trying to accomplish than the money that they're bringing to the table. And it simply wasn't worthwhile. Now that was very, very rare. I think it only happened a couple times over the years. And Terrafugia wound up with a pool of 116 investors in the company that funded us over the course of more than a decade prior to the acquisition. So, you know, that if it had been, if I'd taken everybody who wanted to throw $100 into the company, it wouldn't have worked, right? The overhead of dealing with a huge number of, if it had been 1,000 people, that would have been, I would have been spending all my time managing the investors, you know, expectations and that sort of thing, and not going out and getting the next round together. So, and most investors knew that. You're talking to folks that many of them have been entrepreneurs, have had to do what I had to do previously, and understood the challenges with it. And, you know, as an entrepreneur, you really appreciate those folks because they get it, right? They've been in your shoes. They understand that it's hard. And it takes a lot of time. And so I don't know if that answers the question exactly, but maybe we can come back to that.
So the follow-up to that is, what is your opinion on government funding? Are efforts better spent pursuing private or federal funding? And are SBIR grants worth pursuing?
You know, it all depends on what kind of company you want to have in the end, right? There are many companies that have started up that, you know, SBIR money is non-dilutive capital. And basically I decided early on that I didn't want to create another SBIR shop, right? That I know a lot of people that build their careers building a company that just runs on SBIRs, right? And you can do it. It's non-dilutive. You'll own the company. You know, it's one thing, but SBIRs are not going to create a huge world-changing enterprise. At some point, you've got to take it to the next level. So basically, we put ourselves in a position right from the get-go where we said, look, aside from, we did one government contract. We participated in the DARPA TX program, where it was really kind of an ideal overlap, where DARPA was looking at creating a vertical takeoff flying Hummer, right? And so it was a win-win situation to participate in that one. But we were a sub to a much larger prime contractor, and it was a BAA, so it was going to be a much larger chunk of money than like $100,000 or what have you. That's typical of a normal SBIR. So for that, in that one instance, we made an exception. But in general, we said, look, I don't want to be running an SBIR shop. There are plenty of companies out there that can do that. It doesn't interest me. We have a vision. We want to achieve the vision. SBIRs are going to be a distraction from that. We want investors who are bought into the vision. And that's that we, for the most part, aside from the DARPA program, held true to that.
We have one last question, Carl. What kind of software, flight controller, avionics do you use on your rotable aircraft?
Well, the transition, which is the rotable aircraft that I think they're referring to, it's not a it's not a fly-by-wire aircraft. It's a traditional general aviation aircraft. So it has mechanical linkages between the stick and the elevator and the ailerons, and mechanical linkage between the steering wheel and the front wheels, and between rudder pedals and the rudders, and between the throttle and the throttle cable on the engine. So it is very much designed to be a simple light sport aircraft that has its added capability of folding up its wings in 40 seconds, driving on the road at highway speeds and parking in a garage, because that's what we felt delivered the most value to the customer. So now we do have avionics that we install in the vehicle that are more or less off-the-shelf avionics, like the Diamond Skyview system, which has synthetic vision, GPS moving map, engine monitoring, all this sort of thing. But we don't have a flight computer that has programmed in flight controls. The transition is a traditional GA aircraft. It is stable. It is controllable by a pilot, the same way a pilot can fly a normal Cessna.
Great, thank you, Carl, so much for that incredibly informative lecture, sharing your story. I'm sure it will be incredibly valuable to all of our participants in the Go Fly Prize. We look forward to sharing more questions with you as they come in. And thank you so much.
Great. Thanks a lot.
Take care, everyone.